And he asked, because his basic background is teaching mathematics, he asked, what are the elementary competencies which are involved in solving this type of elementary geometric problems, which are around the theorem of Pythagoras. And here we have the 6 competencies, the 6 elementary competencies, which he as a teacher found to be relevant for solving this type of problems. For instance, knowing the theorem of Pythagoras. And the abbreviation in this case is P. And so on. So you have to take into mind that these capital letters are assigned to the domain-specific elementary competencies. And next step is to ask, what are the states for this set of competencies? So we can define the dependencies between the elementary competencies, and finally this results in a competence structure with 32 competence state. It looks like this. So you easily can see that. And this is on competencies. Either the person has no competencies in this domain, or all the competencies in this domain, and of course the competencies state are in between these two competence states. And based on the competence structure, 10 geometry problems have been constructed. Of course, you have to assign the competencies which are necessary to solve each of the problems by analyzing the solution process to identify the possible solution ways which, applying the elementary competencies, you can assign the competencies directly to the problems. And here we have all the problems, A, B, C, small letters. And here we have the interpretation function. That means in order to solve the problem A, the competencies H and P, K are necessary. To be honest, this approach is a higher level of knowledge space theory. To interpret this, it means you either can solve problem A by having the competence H, it's called the Höhensatz in German, or you can solve the problem A by having the competencies P and K, that's the Pythagoras, theorem of Pythagoras, and the Kathetensatz called in German. So this is an abbreviation. So you either have to have this competence state or that competence state in order to solve this problem. That's you have to know in order to interpret correctly this example of an interpretation function. On the other side, we have the representation function. On the left column, we always have the possible competence states, and the representation function assigns all those problems which are solvable in the corresponding competence state. In this competence state, Ka, for instance, the problems B and C can be solved, and so on. So this we can skip in some sense. In any case, this approach easily can be used also in e-learning systems, and one of these systems which is based on this is the so-called ARPLS, which has been developed by Trinity College Dublin in cooperation with Graz University. So let's come to the ontology-based skill approach, which is in some sense a specialization or maybe specialization of the competence performance approach. Some of you already know what a concept map is. It's a set of propositions, and the propositions connects two related concepts. This is a very simple concept map which tries to visualize the concept of a concept map. And the meaning is a concept map is composed of linking phrases. A concept map is composed of concepts. Concept map identifies relationships. The relationships are between the concepts. Those of you who are master students have already this more elaborated definition of concept map. In any case, the question is, if you have these concept maps, what are the advantages and what can you do with them in order to solve our problem how to generate the structures? And in our example of geometry of the right triangle, we have here the concept map for the whole domain. So this is the concept map. This is the set of all the propositions, of all the knowledge which an expert has. So please, it's of course a very small domain, so we only have a small concept map or a small simple ontology. And the question is how to define by the concept approach, by the domain ontologies, how to define the competencies. And in this example, the question is how to define knowing the theorem of Pythagoras. And if you go into detail, which are the concepts which are involved and which are the propositions which are involved in the theorem of Pythagoras, you easily can see that this is the concept map for the competence knowing the theorem of Pythagoras, which is declarative knowledge or concept knowledge. So by this you can define the competencies, the elementary competencies. And in order to derive the relations or the relationships between the problems, of course you have to define also the problems in terms of propositions or concept maps. So we use the same structure for defining the concepts which are involved in solving the problems. In this example, we have the problems A, B, and C, and we ask which are the corresponding propositions to which are assigned to these problems, and we easily see these are the concepts assigned to this problem, and so on. And if we take again the subset relation, then we can order the problems using the concept maps assigned to each of the problems, because in our example, the concept map of problem A is in some sense a subset of the concept map of B. This is the difference. This is not in A. So A is subset of B. And C is subset also of B. Where's the difference? These are the concepts which are not assigned to C. So C is also a subset of B. However, A and C are not comparable by the subset relationship. In any case, for all the, in our case, 10 problems, we can use these methods in order to derive the prerequisite relation between the problems. Another component are the action structures. Solving a problem does not need only to know about the concepts or the declarative knowledge. Also some actions are involved in this. And the question is how to combine concept structure and the action structure in order to get a whole picture and the whole structure of the problems. The learning experience requires actions of the learner as well cognitive and manual actions. And one action precedes another one. That means one action is a prerequisite for another action. In this simple examples, in the action state a theorem is a prerequisite for apply a theorem. So if you take the different cognitive possible actions, you can ask yourself, is some action involved in another one? And if yes, these two actions are connected by a prerequisite relationship and are in the prerequisite relation for actions. And a skill, we now use the term skill, is a combination of the conceptual knowledge, which is called competence, and action. So a skill is a pair of competence and action. In these examples, you see state, the altitude theorem, is one of these combinations. Apply the altitude theorem is another one. Apply the theorem of Pythagoras is another combination, and state the theorem of Pythagoras is another one. So a skill structure is a combination of the competence structure, which we derived already from the concept maps, and the action structure. So the skill structure is a combination of both. And this is explained or visualized by this slide. We have the competence or concept structure, and in this example, theorem of Pythagoras is a prerequisite for the altitude theorem corresponding to the curriculum, and the action structure of the other side, the state, is a prerequisite or precedes the action apply, and these two structures can be combined into these structures, into this structure and this prerequisite or precedent structure for the problems. Each of the problems is defined by these pairs, and in our example, I'm talking about problems. Sorry, these are the skills. This is a skill structure. So this pair is a skill composed of a concept or competence and an action. And so easily you can find the prerequisite relation on the set of skills. And we can assign, of course, in order to have empirical content, assign the skills to the learning objects. And the learning objects also can be described by the ontologies, and the skill function assigns to each of the learning objects the required and tested or taught skills. And the learning function assigns to each skill state the learning objects that can be processed. That's more or less the same as in the competence performance approach. The advantage using the ontologies or concept maps means that the learner and the needs of the other stakeholders can be described in a common interrelated framework, and a strong relationship with, for instance, conceptual graphs will allow semi-automatic generation of concept maps on the basis of digital information in test books, official documents of the ministries, and so on. This is current research. And also the distributed information in the semantic web, which is under construction, will be usable by the system in the future. So briefly we come to the validation topic. According to my schedule, we have another 10 minutes.